Hi, in this video we will be learning about how to identify relations and functions. But first we need to know what is a relation. Simply, a relation is a set of ordered pairs. In this example we're talking about the height of giraffes, their age compared with their height. So at age 18 the height is 4.25 meters. What you're going to do in your relation is make this a set of ordered pairs. You'll take your domain and your range and put them in the notation of an ordered pair. Therefore, the age, height, ordered pairs here form a relation, which is the set. Very simple. In finding your domain and your range, as I mentioned in the other slide with the heights of the giraffes, your domain is simply the set of the first coordinates of all the ordered pairs in the relation, all of your x values. Your range is the set of the second coordinates in the y values. In this exercise we will find the domain and range of the ordered pairs from the giraffe data in the previous slide. We had 18, 425, 20, 440, all the way up to the bottom of the chart, which was 18 and 485. When you want to go to list just the domain, you'll take these first coordinates of each ordered pair. But you need to keep in mind you're going to list the values in order numerically, from the smallest to the largest, and you will not repeat any of these. As you can see, the 18 years was listed twice because they had two different heights for 18-year-old giraffes. You'll write the word domain with a colon, use the curvy bracket, and then list them in numerical order with commas separating them. Your range, you take the second value of the ordered pairs and do likewise. So here you have the domain and range for the table for the giraffe's height. Next, we're going to find the domain and the range of this relation that's represented in this table. As you can see, the domain has 4, -2, 1, 4, -1. So you'll notice we have 2 4s and 2 -1s. In listing the domain, you just want to take these first values, but you can only list them one time and in numerical order. The -2 is your smallest number, so you put it first, comma, then put just one of the -1s and one of the 4s closed by the curvy bracket. Do the same for the range. In this one you have 2 3s and 2 +1s. Therefore, again, you'll start with this -2, +1, comma, 3. And that gives you your range for this and domain for this table. To identify a function is a special type of relation in which it's a relation that assigns exactly one value from the range to each value of the domain. You may want to think of it as you cannot repeat your x values. We're going to use in this slide a mapping diagram to determine whether a relation is a function. Your mapping diagrams are these type things where you list the domain and range and you point to the connecting ones with arrows. So if you would look here in this example, we've listed the domain and range values in order. We've used them only one time. And then in step 2, I have drawn arrows between the corresponding values. So this would have been an ordered pair 11, -2. Which I've listed in this chart, the mapping diagram, this way. And you can see they're connected with an arrow. One of the other ordered pairs we had was 13 and -2. And as you can see here, the arrow connects up this way. We had 12, -1, and 27. So as you can see here, this would be a function. because there's exactly one for each of these values. But look on this example. As you can see here, a -2 matches with two different values in the range. And as you can see by the definition, it has to be exactly one value in the range. So if you have your mapping diagram and you have one of your domain values going to two different values in the range, this is not a function. The function has to have exactly 1 to 1. A little trouble with my charts. On this one we have identifying a function part 2. In the last slide we used the mapping diagrams. This is another type of test. It's called the vertical line test. And in this one we're going to determine whether the following relation is a function. So the first thing we have to do is graph the ordered pairs on a coordinate plane. 3, 0. You'll go over and up none. This one you go to the left 2 and up 1. Then we go up over none but down 1. Then we go to the left 3 and up 2. Then we go to the right 3 and up 2. For the second step of the vertical line test, we will now pass a pencil or any straight object across the graph vertically. If you have a sheet of paper, you could also draw a vertical line. If you have a vertical line connecting any 2 points, it is not a function. So in this case, we have 3's that line up on the vertical, which creates that this is not a function. According to the vertical line test, you can only have them pass through any one point on the graph, or it is not a function. And for our last part of the video, we're going to test these following sets of ordered pairs or relations to see whether they are functions. First thing I've done here, I'm going to use my vertical line test. I have graphed each of these points on my coordinate plane, and then I can take my straight object to look to see if any of these line up vertically, and you can see they do not. Therefore, this graph is a function. So we'll circle is. What about this one here at the bottom? We use a mapping diagram in this example. We have each of our ordered pairs, and I've taken the first values. I have placed them in numerical order, using them only one time, into my domain. So as you can see, the smallest one was a -4. Then we have 3, 8, and 9. And as you can see, we had 2 3s, so I only used them one time. In the range, I put them from smallest to largest, -2, 0, 1, 2, and 3. My second step is then to draw the lines to the coordinating values. I did well. These only have 1. But as you can see, I had 2 3s, and they have different range values. So this is not a function. That's all for this video.